Today we're going to discuss section 6.5, which is the subject of the law of sines. Okay, so first of all, just an overview. In the previous sections, we've been talking about how to use the right triangle with trigonometric functions. Now, not all triangles are right triangles, so with the law of sines, we're going to learn an additional method to figure out the angles or the measure of the sides of triangles that are not necessarily right triangles. My ink is drying, so I'm choosing another pen. To find the length of a side or the measure of an angle. And here's the important part. In any triangle. Okay, that's what the sign of the law of sines does. Okay, so here's the basic formula for it. You have some. Well, I should draw the picture for it first, and then we'll look at the formula. So let's draw that here. Something like that. And a line that goes like this, maybe, and a line that goes like that. Like this. Okay, so labeling these, we have A, B, and C. And then the side opposite of angle or node or vertex B, let's call that lowercase b. And the side or the side opposite of angle A, let's call that with lowercase a. And the side opposite of this vertex C, let's call that with lowercase c. Okay, so the reason I labeled these sides and angles like this is because the formula would make a lot more sense if they are labeled like that. But we can label them anything. So given a triangle like this, and then the sine of A divided by the sine of this angle divided by the length of the side opposite to that angle, or A, that ratio is equal to the ratio of sine of angle B divided by the length opposite to that angle, side B, which is opposite of that. So side B is opposite to the angle B, side A is opposite to the angle A, and so on. And finally, sine of capital C divided by side C, the length of side C. So that is the law of sines, like that. So let's immediately use it in an example. You've probably seen this in basic high school trigonometry, so this would be a review. And if you haven't seen it before, no worries. It'll be an introduction to it. So here we're saying, specifying that use the law of sines to find the indicated side x. So apparently one side, and I'll draw the picture in a minute. So the side x is what we're looking for, and also the side x and angle theta. Okay, so let's see what the picture is like. So we want to draw something like this, maybe like that. Well, I want to move up so you can see this, like that. And an angle aside like this. And of course, let's connect those two vertices like that. Okay, so this would be 102 degrees. We are given all this information. The length of this side is 185 units. And by the way, this is vertex or angle C. This is A, and this is B. Like that. And we have more information. So this is the side we're looking for, X. And this angle here, we know it is 28 degrees. Okay. And that's all. And we're looking for theta. Well, theta would be that one. Like that. Okay, so theta is easy to find, right? Because the summation of all the angles inside any triangle should be 180 degrees. So we can add these 2 degrees and subtract it from 180. So and that's angle theta, which is, or angle C, I guess we can call it. So let me correct that, because we're going to use the law of sines. So I'm going to use that to say, well, it's theta here, so it's fine. I'll leave it alone. So the angle theta would be equal to 180 minus those 2 angles added. So 102 plus 28. So that'll be 180 minus 130, or 50 degrees. So that's the angle theta. Okay, so the length of side X, now we can use the law of sines, right? We can use the law of sines to write as follows. We know that we just discovered the measure of this theta angle, which is 50 degrees. So we can write sine of 50 degrees divided by the length of the side which is opposite to it, which is X, equals to, we have the other side given to us, so we're going to use the sine of 102 degrees like that, divided by the length that is opposite to it, or 185. So this is basically using part of the sine, the law of sines. Okay, so we can cross multiply, and the rest from this point forward is just basic algebra, right? So we can cross multiply. So we have, let me do that. So we have sine of 50 degrees times 185 equals x times sine of 102 degrees, right? So now we want to solve for x. So x is equal to all of this side, or sine of 50 degrees times 185 divided by sine of 102 degrees. So then we have, using our calculator, we're going to have x equals, notice how many decimal places I use in the middle of my calculation. So in the middle of my calculation, I don't round too early, and then at the very end, I round then to whatever decimal places I like. But in the middle of calculations, if you round too much too early, your final answer is going to be way off. So you can see what numbers I'm using right now, for example. So 0.76604, so I kept 6 decimal places, times 185 divided by 0.9781476, and so this will be, if you calculate this, this will be roughly, I'm rounding this to 144.9. So that's the length of the side x in that figure, like that. Okay, like that. Okay, so let's see another example. By the way, so please remember, when we're solving a triangle, we need to figure out the length of all the missing sides and the measure of all the missing angles. Okay, so that's when we say solve a triangle, that's what we mean. So this is C, that's vertex C, A, and B. And then we can call this, let's call it theta 1. This is 80 degrees. Let's call this theta 2. Right? We don't have the measures of those angles. And then we don't have the measure of this side. Because it's across from this angle C, then I'm going to call this side lowercase c. And then the length of this side is given as 6.5, and the length of this side is given at 3.4. Okay, so solving this triangle in this case means we need to find what the measure of theta 1 is and the theta 2, and then we need to figure out the measure of side C, or AB. Okay, so for sine, for the theta, we can easily take the sine of theta over 3.4. Let's do that. So sine of theta 2 over 3.4, and set it equal to the sine of 80 degrees over 6.5. Like that. So if I'm using degrees, obviously, but if you use radians, it's the same thing because you're dealing with ratios here. So you can use radians if you want to. Let's see. Okay, so we have, let's cross multiply here. Sine of theta 2 times 6.5. Eventually, we're going to have to use the inverse sine, right? Because this is going to give us the sine of theta 2, but not the theta 2. So to get the theta 2, we're going to have to use the inverse sine function. That's why we had to go through the inverse trigonometric functions before we got to this point. And so, and then of course, a sine of 80 degrees multiplied by 3.4. And this, so then sine of theta would be all of this divided by 6.5. Right? So sine of theta 2 is equal to divided by 6.5. And so let's calculate that. Sine of theta 2 is equal to 0.984807753 times 3.4 divided by 6.5. So this may be excessive, but I guess if you rounded this number even at this 8, your final result should have been very close or identical to the result that I'm getting. But I kept all of that. And then, so we have, after multiplying, we're going to have sine of theta 2. What I got, please double check my numbers at home when you're watching this. So 3.3483 divided by 6.5, and that is equal to 0.515130, or you can just not write that 0 at the end. Okay, so this is sine of theta. So this means theta 2 is equal to inverse sine of this measure. Like that. So we need to calculate the inverse sine of that using our calculator. I did that, and I got theta 2 equals roughly 31 degrees. So that's one of the angles we wanted, right? That's theta 2. We also need theta 1. That's much easier than this, finding this theta 2, because all we have to do is add theta 2 and 80, subtract it from 180, and we get that, right? So theta 1 is equal to 180 minus 80 plus 31 degrees. And so we get theta 1 equals 69 degrees. 69 degrees. So that's the second angle. We found the theta 2, theta 1. All we have to do now is find C this length of the side AB because we have the other two sides. And for that, we can take, once again, we can use one of the angles that we just found, right? We don't have to stick with, we can go with sine of 80 over 6.5, then sine of theta 1 over this measure angle C. So let's do that actually. Let's use the angle we just found. So we'll have to use either theta 1 and theta 2. So I'll just use theta 1. If you use theta 2, you should get the same result. So then sine of theta 1, which we just got 69 degrees, over this missing length, C, which is the side opposite to it. So sine of 69 degrees divided by C, which is what we're looking for, divided by sine of 80 divided by the length of the side opposite to it, which is 6.5. Okay, so we can cross multiply again. We can do so sine of 69 degrees times 65 equals C, the length of the missing side, times sine of 80 degrees. So C would be these two, the product of these two, divided by this sine of 80. Like that. Okay, so the rest is just using our calculators and finding this measure. So C would be equal to sine of 69 degrees. Sine of this measure is, I got 0.93358. Notice that I kept 5 decimal places times 65. So you definitely don't want to round this to, say, two decimal places, right? 0.93. It's going to throw off your final result by a large margin. Sorry, this, I need to make a correction, guys. This is 6.5, not 65. So this is 6.5. This is 6.5. And this is also 6.5. So that's the correction. And then divided by sine of 80, which I calculated as 0.9848077. And so C is equal to 6.06827 divided by 0.9848077. So finally C, the length of the missing side, is, after rounding, we get 6.2. So I got 6.16, but I rounded the 1 to 2 after that. Okay, so let's do another example. So we want to, so for the triangle shown below, find the length AD. Okay, so let's see what the triangle looks like. Like that. And then we want to connect these two sides, or these two vertices, like that. And then there is an extension to this. And I want to draw that with a different color, I guess. I'm guessing that'll help in understanding how this example works. I hope it doesn't confuse anyone, but this triangle has that, an extension like that, and then we have connecting that too. Like that. And AD is from here to here, from this vertex to this spot here, to this intersection. So we know we want this, right? That's the question mark for us. But let's see what information we are given. We know that this is called B, this is called C, and then we also know that this angle is 25 degrees. We are told that this is 12. The measure of this side is 12. And we know that that angle, this angle here, is also 25 degrees. And what else do we know? We know that the length of from here to here, AD is question mark, but from here to here is 12. What else do we know? And this is called theta. So this angle is called theta, and this angle is called beta. And what else? So we don't have this angle, but that's the main question for us, to find the length of AD. But we do not have the measure of this angle either. And we don't know what the length of this side is either. It's not been given. Okay, so the first thing we should notice here is that this side and this side are equal. So let's write that down. So note that the sides BD and DC are equal in length, right? That's the first thing we should notice. So if that's these two sides, so this is an isosceles triangle. So i.e. The triangle BDC is an isosceles triangle. Okay? Because of that, if we know this is for any isosceles triangle, if this angle is 25, whatever this angle, the other one opposite to it should be equal. So we know that that angle is also 25. So therefore, what do we want to call that? Do we want to call it C? Let's call it lowercase c. So the angle C is equal to 25 degrees. That's that angle here. Angle C is that angle here. Okay, it was a question mark, but now we know what it is. It wasn't given. Okay, so now we have, and we know that's 25, and we know the other side was already 25. We knew that. So now we can calculate this theta, right? If we know this is 25 and that's 25, we can calculate what theta is, because theta is equal to 180 minus 25 plus 25. So let's write that down. The angle, let's call it angle theta, is equal to 180 degrees minus 25 plus 25, or 130 degrees, right? So we now know this. So if we know theta is 180 from elementary geometry that we learned in high school, we know that this whole thing is 180 degrees, right? That whole thing. But now we know theta is 130 degrees, so beta is how much? It has to be 50 degrees, right? So let's write that down. So angle beta is equal to 180 degrees minus 130 degrees, which is theta. So we get 50 degrees. That's beta. Okay. Now, if we know beta, so now we can calculate angle A, right? So angle A is 180 degrees minus beta plus 25. So angle A is equal to 180 minus beta plus 25 degrees. It's right in that corner. So, and beta is 50 degrees, so we know that, so that is equal to 180 minus 50 plus 25. So this will be 105 degrees. That's angle A, okay, which is that angle. Okay, so we were looking for AD. Now we can use the law of sines, because we know what A is, which is 105. So sine of A divided by 12 is equal to sine of 25 divided by dA, right? By using the law of sines. Once again, we can find dA or AD using the law of sines. How? Sine of 25 degrees divided by AD should be equal to sine of A divided by 12, which is the side opposite to it. So let's write it down. So we have sine of 105, sine of this angle divided by the side opposite to that. Opposite to angle A is this side 12. So sine of 105 divided by 12 equals, we're looking for AD, so we need the measure of the opposite, the angle opposite to it. So sine of 25 degrees divided by AD. So let's cross multiply actually. So I want to, well, I don't want to jump ahead, so let me correct that. So AD cross multiplying, because we have one full fraction on this side, one full fraction on this side, so we can cross multiply, right? So AD times sine of like that. Therefore, AD like that, right? All of this divided by sine of 105. Okay, so here are the values that I used off of my calculator. 12 times 0.4222618 divided by 0.9659258. And finally, AD is equal to, I rounded the final answer to 5.25 units, like that. Okay. All right. So this was a short section, but we learned about a very useful formula, the law of sines, which helps us figure out the measure of angles and sides in triangles that are not necessarily right triangles. Okay, so you could use this with any triangle, right? You could use it with right triangles as well. So with that, we'll reach the end of this video. I hope to see you again for the next video. For now, and have a nice day until next time.